Okay, so I went over how to solve something like this using a graphing calculator the last time, but this time I'm actually going to go over a way you can do it without a graphing calculator. So first we're going to get 0 on one side of this. I'll do that just by subtracting 12 from both sides. So you can write it in the form x squared minus 2x minus 15 is greater than 0. And then the next thing we want to do is graph y equals this thing. And I say graph, but the graph can be a really ugly graph. We only need a little bit of information from the graph in order to see what we need to answer this. We only need the x-intercepts and whether the graph opens upwards or downwards. So, and let's go through that and see how that really rough sketch of it will help us answer this question. So first of all, the x-intercepts of this, when we have y equals this thing, the x-intercepts are the values of x that make this equal to 0. Because if you want to set y equal to 0, that will be at the x-intercepts. And that's going to tell us the boundary points of when this whole thing changes between being positive and negative. So to solve this equation, you could do all of the stuff from chapter 3 and 4 that we've done. You could use a quadratic formula. You could factor it. You could complete the square if you have a lot of time on your hands and you want to practice completing the square. For this one, this is factorable, so I'm just going to factor it as x minus 5 times x plus 3 equals 0. So that means the values of x that make this equal to 0 are going to be at x equals 5. That makes this first part 0. And at x equals negative 3. That makes the second part here 0. So what that means when we make a rough sketch of it is that gives you values of x where it crosses the x-axis. So x equals 5 is here. It has that 1 point and the point negative 3, 0. And so we have those points, and we also need to know, does it open upwards or downwards? And the easiest way to tell that, if it opens up or downwards, is to look at the coefficient of x squared. If it's positive, which it is positive here, that means it's going to open upwards. So we're going to have a graph that looks something, I don't know, kind of like this. That's a graph of y equals x squared minus 2x minus 15. So now why does that help you answer the question? Well, because if we're trying to solve this thing, the graph helps you because on the graph, x squared minus 2x minus 15 is the same thing as y. So you can rephrase this question as what values of x makes y greater than 0? Because, of course, y and x squared minus 2x minus 15 are the same thing. So what x makes y greater than 0? Well, y is greater than 0 at all of these y coordinates. But we really care about the points that are actually on the graph of this, which is where y is equal to the x squared minus 2x minus 15. So at those points on the graph is where y is greater than 0. But what the question is asking about, if we want to solve this thing that's describing x, is what is the x that makes that work? So I'll write those values of x on the x-axis here. I'll just shade this in. So we either have values of x that are over here, such as x is negative 4 or negative 5. That would be, we could write that as x is less than negative 3. That's one part of the solution. The other part of the solution is over here, numbers like 5.1 or 6 or 10, numbers that are greater than 5. So you write that as x is greater than 5. So you could actually just combine that into a compound inequality like so. And that's really the answer to this. It contains these two parts. Now, by the way, if you're not sure about the direction of the inequalities, one thing you might be able to do to check it is, like, if you think maybe it's supposed to actually be these numbers in here, like x is between -3 and 5. Because if you're mixed up about how to read the graph and the inequalities, try a number. So if you're not sure if it's on the inside or on the outside, try a number on the outside, like, for example, 6. So plugging in x equals 6 into this inequality is going to give you 6 squared is 36 minus 12 minus 15. Is that greater than 0? Yeah, this is going to give you 36 minus 27, which is 9. 9 is greater than 0. So yeah, that sounds like that is the solution. And it's not going to be the stuff in the middle. If you try plugging in something like x equals 0 into it, hopefully you're going to get a negative result, which does not make the original inequality true. So that's a way you can do this. Here's this general method here again. Roughly sketch y equals the thing after you get 0 on one side of it. And just figure out what the x-intercepts are. Those are going to be like the boundary points where your where y changes from being positive to being negative, or from being negative to being positive. So get the x-intercepts, and then just look at the x squared term. Is it positive or negative? Because you want to see whether it opens upwards like this or downwards, because that will change your answer. You don't need anything fancy like the vertex. And this is, by the way, the easiest way to solve these things, either like this or with a calculator. They're both good. But there are other ways you might have been taught how to do things like this. When I learned this, my teacher gave me a list of like 13 different rules for how to solve quadratic inequalities. It depended on whether the graph opened upwards or downwards, and whether it was a greater than or less than here, and it involved memorizing all of this stuff, and it didn't help me understand it any better. So I think this method of drawing a graph will hopefully help you understand the whole thing. And this is a concept that you're going to use in trigonometry and calculus and other classes, analyzing when things are positive or negative based on a graph. And I'd like to give you one quick word of caution here. Don't write this answer like this. As if you write it like this, you're saying that x needs to be both greater than 5 and less than -3. But it's impossible for x to be both of those things. It could be one or the other, but not both at the same time, because there are no numbers that are both greater than 5 and less than -3. So yeah, so don't do that. Write it as two separate things.